Okay, so 4.6 inverse string functions part 1. In that portion, we covered pretty much everything that is in this chart. This is a summary. So if you're talking about inverse or arcsine, then you need to, what you're looking for is the angle or arc between negative pi over 2 and pi over 2 with a sine of x. Cosine, inverse cosine of x would be the angle or arc between 0 and pi with a cosine of x. And then inverse tangent or arctangent would be the angle or arc between negative pi over 2 and pi over 2 with a tangent of x. Then you have the symbols that you need to use to indicate each inverse, and then the domain and range restrictions that we talked about yesterday. So this is very important, this is very important, this is very important, and then you have a sketch of the graph. Okay, so what we're going to do now is look at composition of these functions. So if you remember from chapter 1, when you do a composition of two functions, if they are inverses, when you substitute the inverse in the function, then you should get x, and the opposite is also true. So what happens now, this is where it gets a little tricky, is that if you're looking at sine and you of the inverse of sine of x, then it's only going to be true if you're restricting the domain between negative 1 and 1. And now if you are doing a composition of sine of x, sine negative or arc sine of sine of x, which would be this one, then you need to make sure that it is in this domain restriction. Okay, so and I don't want to get too much into the reasons why that is, but you have a little chart here that summarizes the domain restrictions for compositions. So if you have sine of inverse sine of x, then the domain has to be this. Cosine of inverse cosine of x, that the domain has to be that in that interval. And if you're talking about tangent of inverse tangent, for that to equal x, then it has to be in this domain. Now, if you're talking about the inverse sine of sine of x, then for that to equal x, that needs to be the domain. If you're talking about inverse cosine of x to equal x, this needs to be the domain. And then inverse tangent or arctangent of x, then this needs to be the domain. Okay? So, back to what I told you before you needed to memorize, which is this chart over here. We're now going to look at tangent of inverse tangent of pi over 3. So, because of okay, all right, well, good. Oh no. Okay, all right. So for this here to be pi over 3, I need to make sure, so we're talking about tangent of tangent negative 1 of x. For that, for them to be inverses and equal x, then I need to make sure that if you remember from the other chart that we looked at, you should know that tangent of tangent inverse tangent of pi over 3, then pi over 3 is going to have to be between negative infinity and positive infinity, which it is. So your answer here is just going to be pi over 3. It's just that. That's in the domain. So we're good. All right. For the next one, 3 pi over 3 has to be in the domain of inverse cosine of x, then x has to be between 0 and pi. So now, let me erase this so I have more room here. Okay, so now 3 pi over 2, I need to check what I had before was that cosine -1 of cosine x, the domain restriction was that it needed to be between 0 and pi. Okay, and it is, so it's just going to be 3 pi over 4 because 3 pi over 4 is in the second quadrant, so we're good. Now, arc sine 2 pi over 3. So now the domain restriction here is that, if you remember from the top of sine of x, domain restriction was it had to be between negative pi over 2 and pi over 2. So 2 pi over 2 pi over 3 is not in this domain. So if it's not in this domain, I have to find out the same reference angle. So the reference angle would be pi over 3, and pi over 3 is in the first quadrant. So we should be good. Sine is positive, first, second quadrant, so then it would have to be pi over 3. Because it has to be in that domain and it needs to have the same sign, positive or negative. Okay? So this one here is just pi over 3. So it's pretty much going to be this, but you have to make sure it's in the domain. In this case, this one is not in the domain, which means then you have to find the corresponding one in the domain that has the same value, essentially. So, moving on. Okay, so this one, it's not just enough to find if it is in the domain, because it's inverse cosine of sine pi over 3. So now pi over 3, I am going to work from the inside out. So the angle, which angle has a cosine value that has a sine value of pi over 3. So I'm going to go up there, pi over 3. So pi over 3 would be 60. So we're looking here, okay? So cosine 60 is 1/2, sine 60 is square root of 3 over 2, tangent 60 is radical 3. So sine pi over 3 would be, or sine 60 is square root of 3 over 2, and it's positive. Now the question is, what is the value for what angle has cosine equal to radical 3 over 2, but between 0 and pi. So between 0 and pi, because it's a cosine, it would have to be the complementary angle, right? So it would have to be pi over 6. Pi over 6 has a cosine value. Pi over 6 has a cosine value that equals that and is in the range. Okay? And for the next problem, this is not, they didn't give me one of the reference angles, but they told me they want me to find the sine of the angle that has arctangent equal to 5 over 12. Okay, so which angle has a tangent that is 5 over 12? So let's say I'm talking, about a triangle like this, okay? And if tangent is opposite over adjacent, right? So let's say this is my angle here, theta, and opposite is 5, adjacent is 12. I can clearly see that this is going to be a Pythagorean triple, so the hypotenuse has to be 13. So now the sine of this angle would be opposite over hypotenuse, so it would be 5 over 13. I don't need to know what the angle is because they're asking me for sine of that angle. So my answer here would just be 5 over 13. I just need to make sure that it is in the domain. But it is, because for inverse tangent, if you look up there, it goes from negative infinity to positive infinity. If you refer back here, for the domain of inverse tangent. Domain of inverse tangent, negative infinity to positive infinity. So it should be good. And then the last thing you need to know is how to write an algebraic expression of x that involves these trig functions. So here, all you need to use pretty much is Pythagorean theorem. So arc cosine x. So I'm going to draw my little triangle. And I'm going to say, I know that cosine is adjacent. Remember, there is a 1 there, right? So adjacent over hypotenuse, if that's my angle. Then the question is, what would be sine x? Well, I don't know what this is, but I can write it in terms of Pythagorean theorem, in terms of the other two sides. And I know that this side here would be, well, let's call it y for the, just so I can show you here real quick. Let's say this is y, okay? So if that side is y, I can say that y squared plus x squared equals 1 squared, which means that y squared would be 1 minus x squared, and then I could just square root both sides. So the value of this side here is actually square root of 1 minus x squared. And now it's pretty simple. I just have to write the expression for sine of that angle, which in this case would be opposite over hypotenuse. So my answer should be square root of 1 minus x squared, and that would be over 1, but I don't need to write over 1 because, so that would be the answer. For the next problem, they want cotangent of inverse sine of x. So I'm going to do the same thing here. I'm going to draw a little triangle. And if I'm talking about this angle over here, then if sine would be x over 1, so opposite over hypotenuse. And now this side here would be square root of 1 minus x squared. So cotangent is adjacent over opposite. So adjacent would be this side over here, and then that one would be opposite. So now I can say that the answer, or cotangent of inverse sine of x, would be equal to square root of 1 minus x squared over x. And that covers that. So in a nutshell, what you really need to look at are the domain restrictions. And then I would work from the inside out, just like you have done in the past for any composition. And then determine the answer. So here we go. This is what I really would try to remember or write in my notes for the domain restrictions. Oh man, what happened here? Oh, it's not synchronized. Okay, well, yeah. I guess I'll type it. All right. So the main restrictions in compositions should be, is it gonna fix it now? So sine, this sine -1, or inverse sine. This is very bad. The way it's not synchronized with my, I guess I'm just going to refer back up there. When I write, it's right in a different spot. It's been very confusing to me. Let me see if I do it here. Can I do it here? Maybe I can't do it here. Let me try one more time. And if not, I'll just go back. Oh, here's okay. Okay. So sine -1 x. It needs to be between -1 and 1, including, and then for cosine of arc cosine x, the domain has to be between -1 and 1 again. For tangent of arctangent of arctangent, sorry, the domain restriction is actually nothing, -infinity to +infinity. And then if you have an inverse of the regular function, so this is really what you need to remember. So inverse of sine of x, it needs to be between -π/2 and π/2. And then for inverse cosine of cosine of x, you need to make sure that it's between 0 and pi. And finally including. And finally arctan of tangent of x. It needs to be between negative pi over 2 and pi over 2, not including. So that takes care of that. Okay. So that's it for inverse trig functions and composition of with inverses. Thank you.